Okay, problem two. This is the one where we're talking about the converse, the inverse, the contrapositive, a bunch of the vocabulary words having to deal with logic. So for this question, if you go through and read it, it says if Brian wins the lottery, he will give everyone in the class an A on their final exam. In other words, if maybe lottery, then A's. Now, I realize that's not really English right there, but maybe just this shorthand will make it easier to figure out what we're dealing with here. And the reason why is we can define the converse, the inverse, and the contrapositive all in terms of the original proposition, the one that's given right there, about if I win the lottery, then I'll give everyone an A. So the way your book does it is it gives these things names. It says if it calls lottery maybe P, and then giving everyone an A, Q. Fine. If the original proposition is if P then Q, then what the converse would be is kind of that thing backwards, if Q then P. Or if I'm going to write that in English, if everyone gets an A on their final, maybe I'll write it, if I give everyone an A on their final, then I win or won lottery. And I don't care about past tense, present tense, however you want to write that's fine. Just this idea, if Q then P. In fact, I think some people wrote if Q then P and then got this wrong, and I gave them I don't know, if they're 5 points each, you got 4 out of 5. You knew what you were doing, you just kind of translated a little bit wrong. But this was the answer I was looking for. For the next one, the inverse, the advantage to defining this as if P then Q is we can come up with all of these. The converse is if Q then P. The inverse is if not P, then not Q. So if P does not happen, then Q will not happen. If Brian, or I guess, doing this first person, if I don't win the lottery, then I don't give everyone in the class an A. How about just give everyone an A? Yeah, I'm talking about on the final exam. I'm just lazy. I don't want to write it again. I wasn't nitpicky about anything like that. Something that this is not equal to, it's not the same as saying if I don't win the lottery, then nobody gets an A. That's not what this is saying. I think one person wrote that, and it's kind of a nitpicky thing, so I only took off like a point or so and wrote a little comment to you. But it's different. Not giving everybody an A is different than giving nobody an A. Not giving everyone an A, everyone but one person can get an A, and that would fit that criteria. That's different than giving nobody an A. Anyways, contrapositive. Contrapositive is kind of an interesting one. It's sort of a mix of the two of these. Right? The converse flips the order around. The inverse negates them both. The contrapositive kind of does both. It says if not Q, then not P. So since Q is giving everyone an A, I would say if I don't or didn't or won't or something, if I don't give everyone an A on their final, or maybe this should have been on the, well, whatever, on their final, then I didn't win the lottery. I didn't, or I don't, or I won't, whatever. I don't care. That is the converse, the inverse, and the contrapositive. Why do you care about these things? Well, it turns out that some of them are the same. Some of them are logically equivalent, and that can be really important in math because it might be really hard to deal with the original proposition, but it turns out that the contrapositive is always the same, logically equivalent as the original proposition, which is pretty wild. That if Brian wins the lottery, he'll give everyone in the class an A on their final exam is the exact same as if I don't give everyone an A on the final exam, then I didn't win the lottery. Logically speaking, those are equivalent. And that's what we're getting at here. Which of your three answers are logically equivalent to the given proposition? C. C is. Maybe the contrapositive. You don't have to write this. This is just an FYI. Contrapositive is always is. This isn't a special case with the dumb example I gave. Logically equivalent. Can't spell. Equivalent to the proposition. And then finally, one more little point. So, okay, I guess that explains why you might talk about the contrapositive, why I asked you part C. What about part A and part B? Why'd you bother asking me part A and part B? Well, that gets to this one. It turns out that A and B are logically equivalent to themselves. They're not equivalent to C or the original proposition. Right? It's not the converse is not the same as the proposition. But A and B are the same. It turns out that B is the contrapositive of A. That'll kind of blow your mind if you try to figure that all out. But because this is the contrapositive of this, and something is always logically equivalent to its contrapositive, that tells us that A and B are logically equivalent also. And just as a note, inverse and converse, that's always true. All right, that's the end of the second problem, so I'll end this video here.